Hello everyone, this is developer Ashish, and today we are going to do the third part of the object detection using Tensorflow API series, which is going on right now. Installing and running object detection. The first two part we have done, okay, like installing prerequisites and the spelling I have corrected, okay, and creating virtual environment. And the second part, configuration of CUDA with TensorFlow for NVIDIA GPU users. Note: if you are using Colab, if you are not doing this on your local environment, if you are using Google Colab or any other GPU provider, then you can skip first two parts and you can directly start from third part. Okay. But if you are using in your local environment, if you have NVIDIA GPU, then you have to do this first two part. Okay. But if you don't have a GPU or like NVIDIA GPU, and if you are using Colab uh, or any other GPU provider, then you can skip first two parts and you can directly start from third. So you can directly start from here. Fourth part gonna be training own custom model. Okay, like see, just read here, 90 plus classes. Okay, means the object detection we are going to run has already been trained for 90 plus classes. Means we don't need to train it to detect person, car, bicycle, kite, knife, banana, apple. It will automatically detect and recognize, yes, this is apple, this is banana, this is person, this is car, this is dog. Okay, so we don't need to train it to detect and recognize at least 90 plus classes. Okay, but let's say you want to detect and recognize that class which is not there. Let's say helmet, let's say anything. I think a switchboard. I think switchboard is not there, or mic, or phone charger. I think phone charger is also not there. Okay, in that 90 plus classes. So you can train your own custom model to detect whatever you want. Okay, so we are going to do this project, helmet detection project upcoming. Okay, and the fifth part gonna be potholes detection project using Mask Rcnn. Okay, let me just tell you the difference between see, helmet. If I just go this helmet detection, see, an example, see, or see, or see this example. Okay, helmet getting detected. See, boxes are there, right? We will use SSD model, single shot detector. You can read about it in our fourth part. And in the fifth part, potholes detection, Mask Rcnn, we are going to use this and see. See, we are going to make this. Okay, like mask, it will make mask kind of structure. Okay, mask. So this is Mask Rcnn. Okay, so to detect pothole or to detect anything, either you can use only boxes like SSD model like this, or you can create mask also. Like, you know, you can use Mask Rcnn to create mask here. Okay, we will understand about it more. Okay, don't worry. So this too is upcoming, and let's do this. Okay, let's focus on this right now, installing and running object detection. Okay, so so just write it here, TensorFlow-2 object detection API. Okay, TensorFlow-2 object detection API, and you will land here, read the docs. Okay, just open it and you will find it. See, TensorFlow-2 object detection API. Okay, see, target software version Python 3.8 is given, but 3.6 is running. Okay, like we have installed 3.6 and this software is running on 3.6, means I have tried 3.8 and it's not working. Okay, so better you should use 3.6 as we have installed. So see, contents, in the contents we have done the first part, you know, installing Anaconda, creating a virtual environment and activating. The second part, TensorFlow installation and CUDA, CUDN installation. Okay, we have done this. Now today the third part gonna be this TensorFlow object detection API installation till this 3 out examples. And the fourth part gonna be training custom object detector, okay, which I'm gonna make a separate tutorial for helmet detection and potholes detection, right? So let's do our first part, like third part, TensorFlow object detection API installation, and see, click on this, downloading the TensorFlow model garden. Okay, first of all, we just need to download the TensorFlow model garden, right? See, TensorFlow object API installation. Now that you have installed TensorFlow, like we have installed, right, 2.2 GPU, it is time to install the TensorFlow object detection API. So to download the models, you can either use Git to clone the the TensorFlow model repository. So let me just directly go here. Let me directly go new tab and see, this is the models folder. Okay, sorry, this is the models repository, TensorFlow model garden. Just download this. Okay, and then some steps we need to do: protobuf installation, Coco API installation, and then object detection API installation. That's all. These 3 steps we need to do, and then at last we will test our installation, and then we will deal with the codings. Okay, so I think okay. So see the folder structure. We can make a new folder as TensorFlow, and we can store everything there. You can name it anything you want. Okay, TensorFlow or TFOD, that is TensorFlow object detection, or TensorFlow API, whatever you want to name your folder. Okay. So, and yeah, this zip file, it is downloading, right? So you can download this zip file and you can upload this in the Colab itself. Okay, see, for Colab users or any other GPU provider users, download the TensorFlow model garden zip file, okay, which we are downloading, and upload it in the Colab. Extract it in Colab and do further steps in Colab. Okay, so you need to upload this zip file, extract in the Colab, figure it out how to do, and do the further steps in the Colab. So I'm gonna extract in the D. Let me make a new folder as YouTube. I'm making it for the YouTube, so I'm gonna make it the YouTube, and there you go, YouTube. Okay, and extracting. So instead of giving TensorFlow name folder, I have given YouTube. You can give anything you want. Okay, YouTube, and here we have models master and same C research folder, and in research many researches are going on. This object detection is our folder. This is the object detection folder. Okay, so this research folder gonna be our root folder, main directory. Okay, this research folder gonna be our main directory, root folder. This is gonna be okay. So let me just change my directory. I'm in my D directory now, so change my directory, like research folder in D directory, and change directory to research folder. So now I am in my research folder in my Anaconda prompt, and I am in my environment, right, TF40 YouTube. So now let's do further process, like the second is protobuf installation. Okay, so protobuf installation compilation. The TensorFlow object detection API uses protobufs to configure model and training parameters. Okay, before the framework can be used, before the TensorFlow API framework can be used, the protobuf libraries must be downloaded and compiled. So what is this? See, if you go to your object detection folder, this you will find a protos folder. This protos folder, see, these are protos file. Okay, all the file are proto. You need to convert these files into Python file, anchor generator.proto. You need to convert this into Py file, anchor generator.python, Py basically, argmax matcher.py. You need to convert it like this. Okay, so to convert this, you will need a protoc file. So head to the protoc release page, and see, you don't need to download anything here. Okay, protobuf and all, you just you don't need to download anything. See, okay, protobuf Python, nothing you need to download. Just head to this protoc, okay, and for Linux user, choose among yourself. Okay, I'm in the Windows, so Windows 64. I'm gonna download this Protoc. This, okay. That's all. And now I'm let's extract it somewhere. Extract to D in the YouTube. I will extract models in the research folder itself. I'll make a new folder. It will name it as Protoc 3.17 Windows 64 by itself. Okay. Okay. So I have extracted in the here Protoc this. Okay. So if you go to this here, if you go to this folder, you will find a bin folder. In bin folder, you will find a Protoc file. This Protoc file is needed to convert those proto files into Python. So copy this because see, we need to write a code in the Anaconda prompt. This from within TensorFlow models research. Okay, you need to call this Protoc file. So either you can copy this directly in the research folder. So basically, or see, let's just directly copy this Protoc file in the research folder. Okay, like let's paste it here in the research folder. We have copied from this bin folder to this research folder. Okay, so our Protoc file is in our research folder. So let's copy this command. Okay, let's copy this command, and from within TensorFlow models research folder. Okay, so basically from research folder we need to write this command. So we are in our research folder, Protoc file is in our research folder, so just paste it and see Protoc, we are calling Protoc from the research folder. Okay, and under that, like from research folder, it will go to object detection folder, it will go to Protos folder, and it will convert all the Proto file to the Python file. Okay, see, so we have ran this code and you can check from, like, it will go to object detection, Protos, and see, it has converted the Proto file to the Python file. See, anchor generator dot proto, and this anchor generator underscore pb2 dot py. See, this is a Python file now. Box coder dot proto, and now we have its Python version, box coder underscore pb2, and this is Python version. Okay, center underscore net dot proto, center underscore net underscore pb2, this is the Python version. Okay, so we have done this. And now what's the next step? Cocoa API installation, and it's simple. See, as of TensorFlow 2.x, we are using TensorFlow 2.2. The PyCoco2's package is listed as a dependency of the object detection. Okay, API. So we need to basically install this. So for Windows user, this is the code. For Linux user, this is the code. Okay, see, note that according to the package instruction, Visual C++ 2015 build tools must be installed, and it should be in your path. Okay, so if this is not installed, you can download it from here, Visual C++. Okay, so let me copy this pip install Python. Okay, and there you go, and this code also. So Python is getting downloaded, and pip install C, this code also, and the last thing is installing the object detection API. Okay, so if you go a little bit down, you will find, see, installation of the object detection API is achieved by installing the object detection package. Okay, this is done by running the following commands from within the research folder. So from within the research folder, cp command will not work. Okay, basically what we need to do is under object detection folder, under packages, under tf2 folder, we have a setup.py file, and in setup.py file some packages are given which we need to install. Okay, we need to install some packages. So cp command will not work. Let me show you how it will install. So see, PyCoco tools has been installed. So go to your object detection and where it is, packages, tf2, packages, tf2, setup.py. Okay, so just directly copy the path and cd change directory to tf2 folder. Okay, so I am in my under research, under object detection, under packages, under tf2, and under tf2 we have setup.py file, right? So don't write this code also, this command also don't write, just directly write python setup.py, okay, setup.py, and now write install. There you go. See, it will install. Okay, see, this three folders has been generated. Okay, and it's installing. Let it install. This is the last thing we need to do only, and after that we just need to testing, like we just need to test our installations. That's all. So while installing you might face this error. Okay, so Microsoft Visual C++ 14 is required. So if error is showing this, so you better install this. Okay, so well, we got one error. Basically this error is due to Pandas compilation. Okay, it is not able to compile some Pandas thing. Okay, so what you just need to do is pip install Pandas. That's all. Pandas, that's all. And once it will install Pandas, you need to run the same code once again, like same command which we did previously to install object detection API. See, these are some warnings, that's all. And python setup.py install I am running once again, and it will install now. So we have done this, and yeah, so now the last thing is test your installation. So just go a little bit down and see, we need to test if the installation is completed or not. If it is completed, then it will show you like this, run okay, run 20 test in this much second. Okay, so from research folder, so basically Python object detection builders model. So basically you need to run this file, you don't need to install anything else. There is a file called model builder tf2 underscore test.py in your object detection under builders. Okay, under builders folder you have this file, you need to run this file. Okay, so where it is, an object detection builders. Okay, um, this file you need to run, model builder tf2. Okay, so go to your research folder once again. Okay, from there you can run cd, and there you go. Okay, and from research folder you can call python, and you are going to object detection builders, and then this file, it will run directly. So no module named object detection, it will say. Okay, because there is no folder named as object detection under builders folder. Okay, object detection folder is in research folder, right? So just some path issue, so just copy this file and paste it in the research folder. That's why I said na, that research folder is your root folder, everything will run from here. Okay, so now in your research folder, object detection model is there, right? Object detection folder is there, so now it can call object detection very easily. It was trying to call from object detection dot builders import model builder, right? So now you can directly call model builder tf2 from research folder itself. Okay, so now see, it will now run. Now module name matplotlib, you can download matplotlib, whatever it is asking, you just need to download. Okay, pip install matplotlib. No module name matplotlib, pip install matplotlib, just some warnings, and now run that file once again, python, and this file, No module name YAML. So just you can write pip install py. We write like this, okay, pyaml. That's how you need to install pyaml, and it is done. And run that file once again, python model builder, whatever it is asking, just install it using pip. And yeah, see, it's running. Okay, the test is going on. Run. Okay. See, it's going on. Okay. So it is going on. The test is going on. Ran 24 test in this much second. Okay. Alright, so congratulations. The installation is finished. And now you just need to try out the examples. That's all. Okay. Like the codings. And try out the example. Just go to example section and you will find detect objects using webcam or video. Okay. This is object detection from TF1 saved model. So this is for Tensorflow-1. You don't need this. Object detection from TF2 saved model and object detection from TF2 checkpoint. This is for images. Now difference between checkpoint and saved model is saved model means the complete model. Okay, the final model which you want to deploy, which you want to produce. Okay, this is the final model. And checkpoint means, like, you know, when you are training. So let's say for 100 checkpoint. Okay, like for the epoch number 100 or for the iteration number 100, you want to test how the training is going on. So you can use this file, you can use this coding. Okay, and saved model means for the final model. Okay, for the final model, like you want to deploy. Okay, just some one line of code difference in both of them. Okay, you need to change. So download all examples in Python source code and download all examples in Jupyter Notebook. Like both you can download. We're gonna use both. So let me extract this in the research folder itself, and the YouTube in the research folder, extract it, research. Okay, there you go. And Jupyter also. Sorry, YouTube models research, and there you go. So now, so we have extracted our files, and you can see for object detection camera or video, there you go. Like plot object detection, like these are for images, these are for video. Okay, or the webcam. So you can see checkpoint. Okay, like while you are training, when you want to test on certain checkpoints, okay, you can use this. We will use this while making our projects like helmet detection and all. And the saved model, like you can say you can test it on your final trained model on your final product. And this TF1 is of Tensorflow-1. Okay, like you can use it with Tensorflow-1. So let's go to our object detection from saved model. Okay, there is some minor difference, nothing else. Okay, just some minor difference in checkpoint and in saved model. Okay, just one line of path difference. So let me open saved model. Okay, saved model, you can say it will detect right now it will detect the pre-trained 90 plus classes, right? Person, car and all. And if you want to detect your own custom model, like we will do a project, no, helmet detection, the fourth part. So you can use checkpoint. Okay, so see, this is the files. Okay, these are the files, and see, you need to configure your environment. So let me just go here. Okay, so see, there are some like some documentation is given. Okay, downloading the test, downloading the model, down labels and all. Let me just explain. Okay, see, after importing some libraries, okay, and configuring TensorFlow with GPU, there is a function for downloading images. Okay, like we need to download test image, like we need to test images, right? So you can download. See, the link is also given. Okay, so we already have images to test. You can use your own image. Okay, and there you go. Okay, so image path is equals to, see, it will call this function. Okay, download images, this function it will call. Okay, and it will download the images. We already have images, so we don't need to worry. We have images here in the object detection folder. If you go to test images, you will find, see, we already have images to test. Okay, so we don't need to use that particular function. Second function is to download the model. Which model? Okay, like which model you want to work, like which model you want that it should detect your, like it should detect the objects. Okay, which model you want? There are many models like SSD, fast RCNN, faster RCNN, okay, Mask Rcnn, which model you want to use. Okay, so there is a function to download the model name and model date, and the link is given from where it need to download. So path to model directory is equals to model, see, download model, it will call this function, and the model name, it is given, like we have given, like it is given already. Okay, and the model date. Okay, so you don't need to use this function also. We will download whatever model we want. Okay, I'll tell you what is model zoo, and this is label. See, this is function to download the labels. Which label? See, Moscow label map.pbtxt, and this path to labels is equals to, see, it will call this function download labels to download this label file name. This is the label file name. Okay, through this link. So what is the label? See, if you go to under object detection folder under data, okay, in the data you will find this Moss. See, you will find many labels, but see, you will find this Moss ms coco, okay, label map.pbtxt, same kind of same okay, same file. So see, there you will find 90 plus objects. Person, okay, pre-trained one. So we will use this. Okay, person, bicycle, car, motorcycle, airplane. So you don't need to train your model to detect person, bus, car, train, truck. Okay, like those who have made this model, they have already trained for 90 plus classes. Now if there is something like helmet, potholes, which is not there in this 90 plus classes, you can train it. Okay, you can train it to detect that, like helmet, potholes, which is not there in this 90 plus classes, but see, dog, cat is there. Okay, so total there are many, so total around 90 plus classes. Toothbrush, it can also detect. Okay, like it is trained to detect and recognize toothbrush, hair dryer, teddy bear, scissors, right? So all right, so so we don't need to use this function download labels. Okay, we will just simply give the path to this file. Okay, because we already have this file under our data folder, and from here the process will start and it will try to detect. Okay, so first of all, let's go to this download images. Okay, from the first, like let's go to the first function. Instead of using this function, okay, what we can do is we can comment this out and you can just copy this. Okay, image path is equals to, and you can give the path to images. Now where is the image? Under object detection folder, test images, copy the path okay, and here is your images, right? So just give it like this, test images, and the image name, let's say you want to detect image 1, okay, image 1, you want to work on this one, okay, where you want to detect, like you want to test if it will detect the docs or not. So image1.jpg, it is jpg, okay, and you put R because of course you know Python takes everything in this forward slash, okay, and give this in a list, okay, list. Let's say you want to detect the image number 2, okay, image 2 also, like you want to work on this image also, okay, you want to work on this image also, so you can give it like this, okay. So it's like just copy everything, paste it here including this R also, and image 2. So first of all it will render on this image, then it will move to that image, okay, second one. Now if you have hundreds of images, then you know like how you need to write os.list dir, okay, this function you can write, right? So alright, so we will work on these 2 images. Then if you move forward, see download model. So again just comment it out, you don't need to use this function, just copy this, pad to model directly. Now where is our model? See download download the model, okay, you can download this model, see, from Tensorflow-2 detection model zoo. Now if you go here, you will find many models. Now if you go here, you will find many models, okay. See single shot detector is given, okay, like SSD model. If you search single shot detector, how it works, okay, how it works, see how it detects the object, okay, what its procedure, you can search. See SSD mobile net v2, this mobile net you can use it to work on your mobiles, okay, you can deploy this in your mobile phones also, okay. So see, it's always a trade between speed and accuracy. So if the speed is high, the accuracy will be low, and if the speed is low, the accuracy will be high, okay. So you can take any model you want, and the output, see boxes and key points. See outputs, boxes in the key points, okay, like boxes mostly will give you the outputs in boxes. And see for the mask, see Mask Rcnn, it will give you in the mask form, okay, which we are going to use in the potholes especially. So you can use anything you want, okay, anything you want. Like for the boxes, for the mask, if you want to detect potholes using just boxes, you can use anything, you don't need to use mask also, okay. So there is no such a rule or particular rule, okay. So well now if you want to choose the model, let me choose anything, okay, let me choose this SSD mobile net v2, okay. One more thing, if you get any error like resource exhausted error or ohm error, like you know when the memory it is using full memory and it is not able to load that model, then you need to change the model, okay. Like I am facing that memory exhausted error into this kind of models, okay. So better I am gonna use a very light model, okay, very light model. See the speed is like very fast, okay, 19 milli per second, right, okay, 19 milli per second. So it's like so millisecond most probably, or is it microsecond, I don't know, okay. So most probably it's millisecond. And accuracy in precision, okay. So see it just take 19 milliseconds, so it is very fast, right, but the accuracy is low, okay, 20 only. But let me zoom in and you can see this, okay, you can see this. For efficient DET D7, the speed is very slow, 325 milliseconds it will take, but the accuracy is very high, 51, okay. So It's up to you what you want to choose, right? It's up to you what you want to choose. See, if I go to see this one also. Um, Wait. Okay, see this one also. CenterNet ResNet. For this, speed is very fast, only 30 millisecond. But accuracy, if you are working in key points, it will show you 50 accuracy. Okay, in precision. And if you want to detect objects using boxes, then the accuracy is very low. Okay, so it's up to you whatever you want to choose. But yeah, if the memory exhaustion error is coming, so you need to change the model. Okay, so I'm going to use this very light model. Okay, SSD MobileNet V2. So let it download, and we just need to give the path to this model. Okay, that's all. So let me extract this. So I'm going to extract it to the research, or the let me extract this into the where I am, the YouTube. Okay, YouTube models research. Let me extract it to object detection folder. All the object detectors I'm gonna put it in object detection folder itself. So there you go. And now see SSD MobileNet V2. This is now for the checkpoint file. You need to give the path to checkpoint, and we are using this saved model file, right? This saved model.py. You need to give this, like, you just need to give it till here. Okay, it will take this saved model path. See the final output saved model.pb. This is the final pb file. Okay, and this is checkpoint file. See all the training files will generate here. Okay, see checkpoint 0 right now because we have not trained anything. So see, so you just need to give the path to this model. Okay, and you don't need to give it in the list. Okay, so because we are just going to use only one model. So okay, so we have given the path, and see if you go little bit down, okay, you will find, see, path to saved model, path to model directory, the model directory path we have given here. Okay, plus saved model. So as I said, the model path directory we have given plus saved model. So see, that is equals to path to saved model. So the code is written that it will take the path to saved model here. Okay, and it will store here. You just need to give the path to model directory, that is we have given. Okay, so now download the labels. You can again just comment this. Okay, you don't want to use this download labels function. If you don't give the path, it will download the file. Okay, it will download the files, it will download the labels, it will download everything whatever is necessary, and path to labels, and just give it to this data file or data folder, and here is our files, right? So just give it to data folder, inverted comma, slash, and what is the file name? This is the file name, right? It is situated here, ms coco label map. So there you go, .pbtxt, and put r. Okay, so everything we have given, and now the process will start. Okay, so let me configure this settings. Let me put the like this is my project interpreter. So what is our interpreter? The Conda environment TF4D YouTube, right? So show all, and see, there you go, TF4D YouTube Conda environment. If it doesn't show here, you just need to click on plus, and you just need to add, see, Conda environment, and you just need to add existing environment. It will show here. Okay, it will show here, it will show here. Okay, so TF4D YouTube, and okay, and apply, and okay. Mm, why? Is it done? I think, yeah. Okay. So run plot object detection and so let's see. Um, Let it run and it will take some time only. Loading model done. Okay, it has loaded that SSD model, SSD mobile net v2 model in just 21 seconds. Okay, and running inference for see both images and done. It's not showing the image. Okay, it's not showing the detected image. So what you can do is you just need to make one change. Okay, like you can write Tensorflow API not displaying image output. Okay, so you will find this in Stack Overflow. See, you need to use this. Okay, like I know you need to use this matplotlib.use this and it will show you the output image. Okay, see the backend for matplotlib gets overridden to AGG in visualization tools and you can read it. Okay, uh, upon importing, so it will only display images on Jupyter notebooks. Okay, so you need to set it back to something else if you are not using notebook. So we are using Python, so you need to write this. So let me copy and where we have imported matplotlib. I'm just gonna put it below that. Yeah, here. Actually, we have imported pyplot file. Okay, import matplotlib.pyplot. We have imported pyplot. Okay, we have not imported matplotlib. Import matplotlib. Yeah, import matplotlib. Import matplotlib.pyplot splt. Okay, we have imported pyplot from matplotlib, and then this matplotlib.use. We can put it here. Okay, matplotlib.use this use. Okay, otherwise it will show you matplotlib no module name matplotlib. Okay, so you need to import matplotlib also. Now let's see. This is very light model, so it doesn't take much time to load. See, only 19 seconds. Okay, but if the model is very heavy, it will take lots of time. Okay, even running inference will take lots of time. See, the accuracy is not that much good for this model. Okay, like we saw now, we saw the accuracy is not that much good of mobile SSD mobile and v2 only 20. Okay, so what we can do is we can try different model. Okay, let's try like 29 20. So we can try basically whatever we want. Okay, we can try one this faster Rcnn. While I was trying this heavy models, okay, heavy means this 640 by 640. Okay, like the if the image size is bigger, what I am facing problem is resource exhaustion error. Okay, like due to lack of RAM or graphics card. Like I have graphic card, but it's not able to load this image size. Okay, 640 by 640, and so I am having this kind of problem. So if you are having this kind of problem, so better use this 320 by 320. Okay, for 640 by 640 I am facing that resource exhaustion error. Let's try this. Okay, let me try both SSD MobileNet v1 fpn and this MobileNet v2 fpn Lite. This is Lite. Okay, Lite model. So let's see if they both will give good accuracy, because SSD mobile and v2 just gave me 20. Like see, the accuracy is only 20.2 and it actually didn't worked well. So let's try this model, these two models. So let's extract them into object detection folder itself, and models, research, and object detection. Let me just copy this path, and there you go. And this one also. Check 2, here we go. So now we have now most probably 3 models. Yeah, we have already tried this SSD mobile in V2 320 by 320. Let's try this V1 FBN. Okay, then we will try FBN Lite. So V1 FBN, we just need to give the name, copy, and I just need to change the path. So now I just need to change the path. I just need to change the name of the model because after all it's under object detection folder. Now let's try. We have changed the name of the model. Now let's try. Let's see if it's gonna work better or not. So it's taking some time. It's okay, it will take like around 15 seconds to 20 seconds. See, it took 16 seconds to load the model. Okay, loading model done. And now let's see if it can render our images or not, or if it will. So see, resource exhausted error I am facing in this kind of model where the where they work on 640 by 640 image size. Means what they do is they resize the image up to 640 by 640. Our image size, if you check test images, see the image size is 1024 cross 636 like that. Okay, this is 1352 cross 900. This is literally too big. Okay, so what they do is they resize the image to process. So even though they have reduced to 640 by 640, they are not able to work. Earlier we used 320 by 320. Okay, and it worked well. This we used, right? So now let's try FBN Lite if it can render our images or not. So let me change the name to, there you go. Now let's run. Took 17 seconds. Okay, no issue. Yeah, it worked, and it worked well. So this model worked well. See, person, kite. Okay, yeah, kite, person. So if you use little heavy model, it will be able to work pretty well. Okay, like it didn't detected this kite. Okay, but it's better than SSD model, right? Like, sorry, previous SSD model. Previous means that MobileNet V2 320 by 320. And even there also, see, 2 to 3, 4 persons, but earlier into that MobileNet V2 model, it was worse than this, right? So this one worked out pretty well. You can try different models also, like faster Rcnn. This was SSD, you can try faster Rcnn, this one also, okay. But this 1024, it will not able to process because it's not able to process even this 640 by 640. So you can try anything else. Okay, Well, alright, so let's try on the Jupyter Notebook for images, then we will try for video and webcam. Okay, let's complete the saved model for Jupyter. So let me okay, so let me now install here Jupyter Notebook. Okay, you can install in Jupyter Notebook in this particular environments also. So pip install Jupyter, and yeah, and we will load this saved model Jupyter Notebook into our Jupyter Notebook environment, and then we will try on the images, and then we will try on videos and webcam. Okay, so let's complete the images one. So we have done in PyCharm, let's do it in Jupyter Notebook. There's some changes you need to do, like IPython display, something like that, because the images, like here what we did is we have given we added this line now. We added this line, right? So in Jupyter Notebook also we need to add one line, most probably. Okay, let's see. So it's installing Jupyter Notebook, and yeah, done. So now let's open Jupyter Notebook, Jupyter, that's all. I think I need to Jupyter Notebook. Yeah, so see, yeah, oh, okay, it is already loaded. Okay, because we are in our research folder, right? So see, so plot object description dot py, why it's showing on .py format? Oh, sorry, I have loaded .py one, this one IPYMB, right? Plot object detection set model .IPYMB, and others also. So let's try here. See, again same thing you just need to do. Okay, you can just comment this because you don't want to use this function, right? You have your own images. Okay, you have images ready, you don't need to download. If you don't have images, it will download. Okay, if you don't have images, you can use this function, you can uncomment this, it will download, right? So oops, there you go. So let this run. Okay, done. Now again just comment this, and what we are going to do is this, just model directory copy and paste. Done. Download labels again. Sorry. And done. Done. And this is gonna be same, no changes, and loading model. Okay, done. Took 19 seconds, and done. And yeah, just run this. Let's see if it will display the images or not. Otherwise we'll need to add one line at least. So running inference and done. Okay, it is not displaying again. So I think we should put that line. Okay, let's see if it will display the images just like it displayed in PyCharm, or otherwise we'll need to use that IPython display method. So let me put that in, like import matplotlib, and then there you go. And now let's check. Yeah, done. So no worries. So okay, this is done, and now let's try on videos and webcam. First of all, like for videos and webcam both, this object detection camera is needed, and I don't think I have video. So yeah, here you need to give this checkpoint file. Okay, this checkpoint you need to give. Like it doesn't like the code we have, it doesn't take in saved model format. Okay, so you can configure that, no worries. So let's give it, see here it will download it. Okay, so you don't need to download. Path to model TAR. Okay, see. So what you can do is you can comment this. Okay, you can comment some lines, no worries. Okay, and now you can give this path, you can comment this one also. Okay, no worries. Now path to CKPT. So what you just need to do is you go to object detection folder, and we were trying FN light, right? So checkpoint, there you go. It will take this the original checkpoint. Okay, so what you can do is you can just, there you go. Okay, put R, and this configuration file, this pipeline configuration you need to give path, and this is here, right? So just what I'm gonna do is there you go, and I'm gonna put R, and here there you go, slash. So two things we have done, and yeah, and nothing. This label files, yeah, of course you can just simply copy paste. Path to labels, there you go. Let me comment this, and let me put that yeah. Anything else you need to give? Labels you have given checkpoint and pipeline configuration path. There also you just need to give save model, path to labels, and what you need to give here, and the images path. But this is the video, right? So for the video, see, for the video just need to give this checkpoint file, pipeline configuration path, and the checkpoint path, and the labels path. That's all. And which video you want to run? See, if you want to go run the webcam, so this is 0. Okay, if you write cv2.video capture 0, it will open the webcam. If you write 1, it will open the external webcam. If you have external webcam, you can use like 1, 2, something like that. Okay, but 0, it will open the inbuilt webcam. Okay, so, and if you have any video, so you just need to give the video path, just like we gave the image paths, right? So you just need to give the video path. Like, let me try to find any video. I don't think I have any video. I don't think I have any video, I guess. What is it? Duck. Okay, leave it. Okay, let me try to find in my previous projects. In my previous projects I have, just give me a second. You can download from the YouTube also. Okay, we can take anything. So see the potholes, right? We are going to work on this, the fifth part, right? The fifth part, we are going to detect the potholes like this. Okay, we are going to detect the potholes using Mask Rcnn, as I have announced, right? The fifth part, we are going to do this, right? Potholes detection is Mask Rcnn. We are going to use this video, okay, to detect potholes. So let's use this same video to testing. It will detect cars itself, right? It will detect cars because we have not trained it to detect potholes. We will train it on the fifth part, okay. On the fourth part, we will train our model to detect helmet. In the fifth, we will train it to detect potholes. But right now, in that 90 plus classes, in that 90 plus classes, it is not trained to detect helmet and potholes. It is trained to detect person, car, you know, that you can read that MS Coco label map file. You can read that MS Coco label map file, this file, okay, and you will find that 90 plus classes are there, like person, car and all. So let's give the path to this potholes video, potholes.mp4. This is mp4 video. Always check the properties, right? Always check the properties if you are confused. .mp4, okay. So just write the name potholes.com. So there you go, potholes.mp4. Put R, that's all. Oh, here we have not given this. So now model in CV2, you can install CV2 from here itself. Pip install. See, we are in this environment, right? So even if you install from Anaconda or here, it doesn't matter, okay. Open CV Python. So there you go. Okay, all right. Let's try. Let's see how much time it takes and it's actually taking more time. And see, so this is the model's fault, okay. The accuracy is very low. Of course, we are using light model, so kite. But see, the only 31% confidence. So you can set this, okay. If the confidence is more than 80%, then only show the output. See, car, it is detecting, okay. Car and all, I'll tell you. And see, bird, we can set this, you know, we can set this. If the accuracy is more than 80%, then only detect things. We can set this. I need to find, but yeah, it is detecting car and all, okay, like this. Or you can change the model. You can try a different model who is having good accuracy, like here, okay, like this. But yeah, it's not running on me due to resources exhaustion error. It my laptop is not able to load that much heavy model, okay. But yeah, see, that's how it's gonna look. And let's try in Jupyter, and then we will try the webcam, okay. Then we will try the webcam itself. So let me save this, and yeah, there you go. Same thing, just need to change, just run this, and yeah, just what you can do is just copy two lines sincerely, Oops. From here, yeah. Copy, paste, and you can comment this if you want. We don't need it, right? And yeah, this path to label. So there you go. That's all. Yeah, and then load the model. I don't think we need to set anything here. It's gonna load the model. Let me run this one also, and yeah, the video path we just need to give the video path. And yeah, that's all. Just run this. See, this minimum score threshold you can change. Okay, I'll tell you this. Okay, just change it to 80, and if the accuracy is greater than 80, then only show the boxes. Here also you can change 80. Okay, you can change if you want. So I've ran this. See, earlier we didn't change, right? Earlier it was 30 only, so minimum score threshold. So you will again see potholes as birds. Okay, so let it load, let it run. Yeah, so see, airplane, kite, right? Kite and all. So this is not good. It is showing kite and showing I'm 30% sure this is kite. It is saying like that, right? And you will find see bird. Okay, even though it's only show 30%, 35. So what you can do is you can set a threshold value as 65 at least. Okay, so your problem will be solved. So there you go. Let me run this. Okay, I need to run everything once again. It happens suddenly. Just give me a second, okay? Here also you can set the threshold. Everywhere you can set the threshold. So yeah, only aeroplane, this time no kite, nothing. Okay, you can set it to 70 or change the model, of course. See, now a better accuracy because it's only showing the output boxes, which is a confidence, which it is having confidence more than at least 65%. Okay, so see, now our accuracy is better at least. So yeah, that's how you can do it for the video. And let's, like, for the webcam you just need to change one thing, the 0, like the video capture, and you just need to put 0 for inbuilt webcam, 1 for external webcam. Okay, so yeah, that's all. Before we move toward this, what we use SSD model. Once again, SSD MobileNet v2. Earlier we used only MobileNet v2, right? And then we used FPN Lite. Let me try SSD model into the images. Okay, earlier, oh, not here. We were detection. Just give me a second. There you go. This okay. SSD mobile NV2 320 by 320. Earlier we did this where in which minimum score threshold is 30%, and our accuracy was not good, right? Like there were multiple boxes. So this time what we are going to do, like let it run, then we will change the threshold to 70 and you will see less output boxes, but only the important one. Yeah, see, okay, very messy. This one also very messy, right? So let us set the threshold to 70. Let me try now. Yeah, loading model done. ट्रक गया अभी इतना काट देना. Yeah, so accuracy is still not good. Okay, 2% are not getting detected, but yeah, we can see less bounding boxes. So you can play with this threshold value. Okay, so now let's try with the webcam. Okay, so now let's try webcam, and for webcam you just need to change one thing in the object detection camera file, this co2.video capture, and just put 0. It will open your inbuilt webcam, and if you have any external one, so put 1. Okay, so 0, and it will open my inbuilt webcam, and let me set minimum score threshold as 60%. Okay, you can set this also maximum boxes to draw. Alright. Okay, so I have ran this file, and let's see how it will go. My webcam is open. And it will show me one file here. Okay. Okay, so I can see a file, and so person and mobile phones. It sure. Just give it some time. Not responding. It happens. Okay, it's not. I don't. Okay, same resource exhaustion error. Okay, so it's just not like my laptop is not able to load. You can try. Okay, it will load in your laptop, most probably in your laptop or in your PC. If your PC is good enough. Okay, you can. Let me try to change the model once again. Okay, this SSD mobile net. Let me try this model once again. Mobile net. This. Instead of FPN light, I'm going to use this V2. Now let me try. And same you can do with Jupyter. You just need to change the Okay, it's might be loading some time. Okay, so I can see one file, and person. Okay, cell phone. Okay, working. Do I have any bottle? Yeah. Bottle? Yeah. And I don't think I have anything here. Will it detect bottle? Sorry, wallet. Like in that 90 plus objects, no, wallet is not there. Wallet, and no, I don't think I have anything else. Camera. Will it be able to recognize camera? No, most probably no. What is it? Donut. It is saying donut. Okay, you can change the model, right? It will work better. And same you can do with Jupyter Notebook. Let me use SSD MobileNet V2 model there itself, okay, in Jupyter Notebook, because other model it's not able to load in my laptop. There you go. And let me run this, and let me just put 0 here and it will work. 0, and yeah, now it will load. My webcam light is you can say it's glowing. So give it 1 minute at least, right? Person, and okay, so thanks for watching, guys, and if you're new to channel, then subscribe, hit the bell icon, like this video if you found this video useful. And yeah, one more thing, if you can support me, then join my channel. The minimum support, like you can support me 59 rupees per month, or you can say 0 point some dollars only, okay. So you can support me. Most probably it will show you $1, okay. Country wise it varies, but yeah, as an Indian, just 59 rupees per month it will charge you to support me. If you like my content, if you like whatever I am building, so please support me. Thank you very much for watching. And yeah, this look is my lockdown effect. The lockdown is going on here and I'm not able to trim my beard or cut my hair, okay. So thanks for watching. Bye bye everyone, take care, stay safe.